Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
You'll now have a chance to practice some of the ggplot basics on your own. There are 6 exercises for this lab. Let's run through them quickly. Number 1, what happens if you make a scatter plot of class versus drive? Why is the plot not useful? So for this one, we're still using the MPG dataset, and just try to create a ggplot of class versus drive and explain what happens and then why it's not a particularly useful plot. Number 2, list at least 6 different Giome _xxxx functions available, and you can just check online, use some other resources as you see fit. Number 3, map the variable trans to the size aesthetic. So trans is for transmission. Map the variable trans to the size aesthetic. What message is printed in the console, and why do you think that is? Number 4, map city to the color and size aesthetics simultaneously. What happens? So this is something we didn't do in the videos, but it's going to be done the same way. So your variable city will be mapped to both the color and size aesthetics. And so just think about what happens and what that means in your plot. Number 5, what is the difference between this Giome function call and another Giome function call that looks very similar but is a little bit different? So what's the difference between those? And if the data set doesn't have a variable named blue, which one of these calls will produce an error? So you see we have a blue here and blue here. If the data set doesn't have blue, one of these is a variable named blue. One of these Giome function calls will throw an error. You think about which one it is. And then number 6, look up the available aesthetics for Giome point. So we've talked about size, color, size, and shape. So for anything that's not color, size, and shape, find a variable in the data set to map to that aesthetic and describe what each aesthetic does. Let's now go over the solutions to the exercises you just worked on. Number 1 says, what happens if you make a scatter plot of class versus drive? Why is the plot not useful? So let's go ahead and call ggplot. We'll pass it the MPG data set, and then we'll create a scatter plot with Giome point, and the mapping will be that X is going to be class and Y will be drive. And let's see what happens. Aha! So we're able to get a plot, but recall that class is a categorical variable, 2-seater, compact, midsize, etc. Drive is also a categorical variable, R for probably rear, F for front, and 4 for four-wheel drive. It looks like it's the type of drive the vehicle has. And so we get a scatter plot for 2 categorical variables isn't very helpful because all we get is a single data point for the intersection of each one. So for example, this data point here corresponds to the fact that there are observations in the data set that are minivans and also front-wheel drive. So this single data point represents all minivans that are also front-wheel drive in the data set. And so this point, for example, represents all mid-size vehicles that are four-wheel drive in the data set. So we lose a lot. So you could tell there's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 12 data points in this plot, but our data set has 234 data points. So our 234 points have been reduced down to only 12. So we lose a lot of detail about them. Now, this could be helpful if you simply wanted to know what was the cross-section of drive and class. Where did you have observations? But there are other ways to do that without creating a plot. So you wouldn't really do that by creating a plot. So we've addressed number 1. Let's take a look at number 2. List at least 6 different Giome functions available. So we'll just make a list here. There are a lot of them. We've already seen Giome point. There's one called Giome smooth that we'll work quite a bit with. There's one called Giome hex, Giome line, Geome bar we'll talk in quite a bit of detail about later on. Geome density. There's one called Geome histogram, etc. Okay, so there are a bunch of them. There are wrong answers there, but there are also a lot of right answers as long as you looked and found some of those. Now, I will give you a hint. If you're ever looking for some ggplot help and you're working in RStudio, you can go to the go to the help section. There's this thing called cheat sheets, and then if you click on data visualization with ggplot2, that will open your web browser on your machine and will take you to a PDF file that's a 2-page quick start guide, kind of a cheat sheet, and that'll have a lot of your main Geome functions listed there, and other things as well that we've talked about. But that can be a handy resource for you that's worth mentioning right now. All right, back to our exercises. Number 3, map the variable trans to the size aesthetic. What message is printed in the console, and why is this? And so we need to first create a plot in order to do this. So let's go back to our plot that is going to be a scatter plot of, let's just do x is displacement and y is highway, the plot that we've done earlier. And so the size aesthetic is going to be the trans variable. And so you see we get this error we saw before. Using size for a discrete variable is not advised. Generally, you want to reserve size for a continuous numerical variable so that values, observations that have a higher value of that numeric variable will get a larger size, so that the larger size actually indicates something. We don't really want to change size just based on different groupings, right? Based on the different transmission. If you have something like this that's a categorical variable, like we saw before, color can be a helpful one. Color is probably the best one. We'll also, in a later video, talk about another way to do that, to break up the plots based on a categorical variable. And shape can also be a good one, but you have to be wary of shape that at most you can have 6 different classes. So transmission here would not be a good option to do shape because you have more than 6. As we saw earlier, that'll throw an error. But certainly you don't want to use shape with a discrete or categorical variable. You want to use something else. Probably color would have been a better option at this point. Okay. That leads us to number 4, map city to the color and size aesthetics simultaneously, and what happens. So I'm going to steal this same plot so that we have a plot from which to work, and we want to map city to the color and size aesthetics. So we'll map city, and then, so that's to size, and then we want to map city to the color aesthetic as well. And what happens? Well, we get a double aesthetic mapping here. Again, this is something we didn't discuss in the earlier videos, but provides us with a fairly interesting plot anyway. And so what's neat is that we've added a third variable, but we've added it twice here. So that sometimes can be a good idea and sometimes not. What I mean by that is it can get a little confusing. So for example, in this plot, the city variable is first represented by size. So the bigger the marker, the bigger the circle for the data point, the higher city MPG it has. So these data points over here have a higher city fuel efficiency than these data points down here, for example. This is also, city is also mapped to the color aesthetic, so the higher city MPG values have the lighter blue, and the lower MPG values have a darker blue. And so you can see that, again, up here we have the lighter colors versus down here we have the darker color observations. So really the double mapping here is redundant, right? So we can tell that both of these two mappings give us the exact same information. So we can tell that from either color or size, or really color and size, we get the higher city values up here, we get the lower cities values down here. So really, in this case, this was a redundant mapping. Certainly either one would be perfectly fine. It's just that we don't need both of them. But it is good to know, and kind of tuck in your tool belt anyway, that you can do a double mapping. You can map the same variable to multiple aesthetics, which from time to time you might end up in a situation where that would be useful. All right, number 5. What is the difference between a geom function called like this, and then a geom function called like this? And then if the data set does not have a variable named blue, which one will produce an error? So let's first of all just look at the difference between the two geom function calls. You'll notice that in the first one, the color equals blue argument is part of the aesthetic function. So x equals, y equals, and color equals are all listed inside the AES function call, the aesthetic mapping function call. In the second geom function call, the color option, the color argument, is not listed inside the AES function call. So AES only has x equals and y equals, and then color is listed outside of that as a separate argument to the geom function. So what that means is, in the first case, the color aesthetic is going to be mapped to the variable blue. And you'll notice that there are no quotes around a blue, so it's not like we're passing a character value here. We're passing a variable name. So this call has three aesthetic mappings. X is mapped to xvar, y is mapped to yvar, color is mapped to blue, the blue variable. And in this one, there's two aesthetic mappings, and then the color is just explicitly defined as being blue. You'll notice the quotes here around blue, so we're passing a character value to the color option, the color argument. So that's going to make all of the markers blue. And so we'll see then, if the data set doesn't have a variable named blue, which one will produce an error? Well, it's got to be the first call, right? It's got to be the first call, because again, the color aesthetic is being mapped to a variable named blue in the data set. So ggplot is going to go to the data set that's listed in the original ggplot call, and is going to look for a variable named blue to provide the color dimension for. And so if that data set doesn't have a variable named blue, it'll throw an error. And so let's go ahead and see that real quick, just so it's clear what we're saying. Let's go ahead and let's just grab this base plot that we've been working with, where we work with MPG, and our mapping is x is displacement, y equals highway, and let's just try to tell ggplot to use color equals blue, and you'll see that we get then an error, object blue not found. It's looking for something called blue, some object named blue, and no plot is created. It's a blank plot because ggplot got called, but there's no detail to the plot that's been created. So that's the one that throws the error. That leads us to the last question. Look up the available aesthetics for Giome point. For the ones that we haven't addressed yet, find a variable to map to the aesthetic, and what does each aesthetic do? So let's go to our help, and let's look at Giome point. Giome point. And in the documentation for Giome point, we'll be able to find the available aesthetics for this Giome function. We scroll down in the documentation, we see here there's a section on aesthetics. Giome point understands the following aesthetics, and it says required ones are in bold, so X and Y we've already dealt with. Alpha we have not. Color we've done. Fill, group we have not. Shape and size we've done, but stroke we have not. And so for this, we need to, let's just make a list here. It looks like alpha is one we need to deal with. Fill, group, and then stroke. So there are 4 Giome point aesthetics that we've not dealt with yet. Now we could look online and see what exactly these do, but let's just kind of mess around with these and see if we can't figure it out. Let's start with the alpha aesthetic. This can often be, something like this can often be better for you to learn by just playing around with it than going and reading the documentation. You'll remember more if you kind of do it on your own like this. So let's start with alpha. Let's just say we know we can't map it to blue, so that's we can delete that. But let's take the alpha aesthetic, and we know we need to think about, does this need to get a numeric variable or a categorical variable? So let's just give it a categorical variable first. We'll just try with class, okay? And let's see what happens. So it tells us that the alpha value for a discrete variable is not advised, but we do get a plot, and it looks like it's similar to a color, but they're all still black. So it looks like it's almost a grayscale option, or maybe even a transparency option that's provided here. So this says for a discrete variable it's not advised. So let's just, instead of class, let's do city. So we give it a numeric variable. Okay, we get no error there. And then here we see, here we see mapping the city variable. The light colored points have the low city MPG down here. The darker points have the higher, and those sit up here. So it's a different way of scaling by color or transparency of the data points. And in fact, if you wanted to map, say you wanted to map color to the cylinder variable like we did earlier, we could map color to cylinder. Let's go ahead and do that. We can map color to cylinder and then alpha to city, and so that would give us a different color based on the cylinder value. So the 4 cylinders get the darker points, 8 cylinders get the lighter points, and then we add this transparency value based on city. And so again, the low city MPG get the transparent. So down here we see these light blue, highly transparent. So these are 8 cylinders with low city miles per gallon, compared to our dark vehicles, our dark points that are dark blue, that are not transparent. So we get the 4-cylinder with the high city MPG. So alpha is a transparency. It's a transparency or scaling, color scaling aesthetic. So pretty neat. We'll look at fill. Let's see what fill does. Again, we'll start with our base plot here, and let's see if fill equals, let's start with the categorical variable, and so we get that. Fill equals class. Well, it looks like it tried to do something, but really this is just the base plot, and all of these look exactly the same. So rather uninteresting there. It seems like it worked, but it didn't really do anything. Let's try city. And so here, again, it looks like something is trying to happen, but rather uninteresting in our plot. And in fact, with the fill parameter, it's a little difficult in a scatter plot to map these as part of an aesthetic mapping. So let's map them instead. Let's just set the fill directly, and we'll see what's going to happen here. Let's just call it red. And again, we see that we really just get the same black points with no legend. So what's going on here? Well, it turns out that the fill aesthetic actually has to be used in conjunction with another aesthetic. So let's change the shape to number 22. And so the shape is going to change this to boxes, but particularly boxes that can be filled with a different color. And so whenever we run the plot here, now we see that we get a different shape, and we get red values. And you can look, or red boxes, excuse me. You can look online to see the available shape numbers and what the shape that they correspond to, whether it's boxes or triangles or plus signs or whatever, and which ones can be filled. So fill certain shape aesthetics. All right, that's what the fill value does. Okay, now group. Let's work on group. And so again, we'll just take up this plot, And let's try to do a mapping first. Let's try group equals class. Okay, group equals class, and we'll see what happens there. Oh, I was missing a parentheses. Okay, we'll try to group by class. Nothing interesting happening there. Let's try to group by a continuous variable. Nothing happening there. And so, of course, the question is, well, how do I use the group aesthetic? Well, really, with Giome Point in particular, you're probably never going to use the group aesthetic because all it does is group by categorical variables and provide a different feature for that. So really, like we've seen, you have different ways of doing that, whether it be the fill or the shape. So really, you're never going to use this with Giome Point. Now, there are other functions you would use, but not with Giome Point. Now, for stroke, let's go back up to this plot where we changed to the red boxes, and let's just add a stroke option here. And let's just say stroke equals 5. And so you can see what happened was that we still get the red boxes, but their boundary, their border, is so much thicker than it was before. And that's what the stroke aesthetic does. Stroke changes the boundary thickness of certain shapes. So it can be used in conjunction with the shape aesthetic as well to change the look of the shape aesthetic. So the point there was just to expose you to some different aesthetics, and like we've said before, depending on the Giome function you call, and we'll talk a lot more about that in a later section, the available aesthetics to you for that Giome function will change, and you'll be able to make the plot look, however you want for that particular. You'll now have a chance to practice some of this latest material in ggplot, specifically facets, geomes, and statistical transformations. So there are 5 questions in this lab exercise. Let's run through them briefly. Number 1, what happens if you facet a continuous variable? You might have an idea just thinking through that on your own. What I would recommend is that use that MPG data set, create a plot, scatter plot or whatever, and try to add a facet on a continuous variable and just see what happens. Number 2, write the ggplot code to recreate each graph in the sample ggplots attachment. So in the course files, there's a sample ggplots which has several plots there. Just write the code to recreate those plots, pay attention to the detail, and make sure you get exactly the same plot. Number 3, what does Giome Call do, and how is it different from Giome Bar? Again, use the MPG dataset and just play around with that. Look up the documentation as needed. Number 4 it says create a bar chart of manufacturer and map the fill aesthetic to class. And then what does the fill aesthetic do? And based on that, what type of variables should be mapped to the fill aesthetic? So again, is it a continuous numerical variable or should it be a discrete categorical variable? And then number 5, what variable does Giome Smooth compute? And what does the method argument control? So look up Giome Smooth in the help documentation. Look at what variables it computes and then what the method argument controls, just so you get an idea of what kind of control you have, what kind of options you have when you're using the Giome Smooth function. In this video, we'll go over the solutions for the exercises you just worked on. So I'll load the Tidyverse package so we have all the tools in our environment. Now let's address the first question. What happens if you facet on a continuous variable? So let's go ahead and create a ggplot using MPG. And we'll add a scatter plot with, let's use a mapping of x equals city and y equals highway. And then we want to add a facet call, and we want to facet on a continuous variable, so let's just say we'll facet on displacement. Well, what happens here is that we get facets, subplots, for all of the values of the displacement variable. So while it works, you obviously want to be very careful because this resulted in 1, 2, 3, 4, 5, 6, almost 36, looks like 35 faceted subplots. And you see that the values of displacement are found at the top of each one. So while it executes and works, it may not be particularly useful. You can see we only have a handful of data points in each subplot. So we've really lost a lot of the relational behavior that we would be looking for. So what happens? Well, you get a subplot for every value in the continuous variable. We were lucky in this case to only have 35 values of displacement. Imagine if we had had 100 values. In fact, there are times whenever R will even throw an error on that if you have too many. So definitely want to be careful. Recall that faceting is intended to work with discrete categorical variables. All right, number 2, write the ggplot code to recreate each graph in the sample ggplots attachment. And so we'll just go ahead and put this on here. And here is all of the code that you need to create those plots. So I won't have you sit through me typing these out, but we'll go ahead and take a look at them. We'll start with a smoothing curve. We've seen this one in the past, a nice scatter plot with a smoothing curve. And then we'll go ahead and do a smoothing curve that's grouped by drive. And so we have a scatter plot with a distinct smoothing curve that's grouped by drive. And then we have the smoothing curve that's broken out by drive as well as colored by drive. And so we see that. And then we get the single smoothing curve, but still the scatter plot is colored by drive. Whoops. Let me try that again. We had part of it highlighted. Here we get, again, color is set by drive. The Geome smooth is set by drive. And the line type is set by drive. So we get kind of this nice, interesting plot where we have drive featured a few different ways. And then lastly, we have something where the points have their outline in white. The color is set by the value of drive as well. So just the point here is to have you test some of those different features. How do grouping work? How did the line type work? How can you set colors, etc. So hopefully no issues there, and you learned a lot as you were writing those plots about how to set those different arguments in the functions. Now, what does Giome Call do, and how is it different to Giome bar? Well, the way I would do that is look in the documentation. So let's look up Giome Call. We're already familiar with Giome bar. So here it actually takes us back to the bar chart documentation, right? So there are two types of bar charts, Giome bar and Giome Call. We already know about bar. Okay, so here we're told that Giome Call uses stat identity. In other words, it leaves the data as is. So recall when we talked about Giome bar has a statistical transformation that happens in the background. It retrieves the count from your data set. But Giome Call takes the data as is. So let's look at what would happen. So you might think that Giome Call could also take the raw data set, but if we try to do that, let's say mapping equals and x equals class. We did this as a bar chart earlier. Notice it says Giome Call requires the following missing aesthetic, right? So we're going to potentially run into problems here because let's go ahead and view the MPG data set. Right? If we're trying to group on class, clearly Giome Call is looking for something. We've put class on the x variable or on the x-axis. It's looking for a y-axis aesthetic to map to class. So I don't know. Let's try something like highway. Let's just see what happens if we put y equals highway on there. Okay, so again, what's happening? Well, for our two-seaters, look at this scale here for the y-axis for the two-seaters and the compacts and the mid-size. Right? So the highway scale is really quite a bit larger than we would expect for the others, and from the data set, because the highway values are all around 25 to 30, maybe 35 in cases. This is up 500, 1,000, over 1,000, almost 1,500. And so what's happening is Giome Call is trying to take those raw highway values and aggregate them for the group, when that's really not what we want. What we would particularly be looking for would be the counts on these columns. So if you want to do Giome Call, you'd have to create a new data set, like we did earlier with MPG new. We'll call MPG new, and that'll be MPG. We can just take it and group by class, and then summarize so that count is the number of observations. And then instead of passing MPG, we'll pass MPG new, and then we can put count on the y-axis, and then we'll get something that's more reasonable, right? We can actually count the observations in the data set. So it has a similar shape, but now the y-axis actually makes sense. So the difference between Giome Call and Giome Bar: Giome Call has to take the data directly. There is no underlying statistical transformation other than just taking the actual value that's in the data set. All right, number 4, create a bar chart of manufacturer and map the fill aesthetic to class. So we'll call ggplot with MPG again, and we're asked to create a bar chart where we're mapping the X aesthetic to manufacturer. Okay, so here's what the base bar plot is going to look like. You see that the axis text got a little crumbled in the preview down here, but when we open it up, it's the manufacturer on the x-axis. And we are told to map the fill aesthetic to class and see what happens. Aha! Now we get a fairly interesting plot, don't we? So what we get is a stacked bar chart where the stacked groupings represent class. So let's just take one example, Dodge. Dodge has almost, looks like 37 or 38 vehicles. They are made up of, pink is SUV. There's about 8 or 9 there are 6 or 7 that are SUVs. Then there's another group, it looks like maybe not quite 20, close to 20 of them are the blue color, which is pickup. And then the remaining vehicles in the Dodge manufacturer group are mid-size. They're green. Actually, these are minivans. These are minivans, kind of this teal color represents minivans. So Dodge not only has the most vehicles, but they're only made up of SUVs, pickups, and minivans. In other words, there are no seaters, no two-seaters, no compacts, no mid-size, no subcompacts in the Dodge grouping. So the fill aesthetic for the bar chart for Giome Bar provides you with a stacked bar chart. So with that in mind, what type of variable should be mapped to the fill aesthetic? Well, clearly you want to only map discrete categorical variables, and at that, discrete categorical variables that have a relatively low number of groupings. You wouldn't want 15 groupings in here so that you're putting 15 groupings in your bar charts, right? That would not be very useful at all. So, and you also wouldn't want to do continuous variables because they just wouldn't map. There would be no way to create your color distinctions here, right? So discrete categorical variables with a relatively low number of unique values. And number 5, what variables does Giome Smooth compute, and what is the method argument control? Again, we'd go back to the documentation for that, look at Giome Smooth. We can scroll down in the documentation and find that there are a number of variables that are calculated here. It says computed variables. Y is the predicted value. It also calculates Y min, which is the lower confidence interval, Y max, the upper end of the confidence interval, and then SE, which is a standard error. So remember that Giome Smooth calculates a smoothing curve. The stats transformation in the background is to calculate a smoothing curve. By default, it's a low S, and so it's going to create the predicted value. That's what gives you the line in that smoothing curve, and then it also gives you the confidence bands that are based on the standard error, and so that's what gives you the band that's wrapped around that smoothing curve. If you go back to the plots and look at those in the earlier plots, one of the smoothing curves, we saw that there's a band that's plotted around them. We haven't plotted one in this session, but in one of the other earlier videos, you saw that it had a band around the smoothing curve. And then lastly, what does the method argument control? Well, the method tells us what type of smoothing is going to happen. So by default, it's a low S, but you can do an auto smooth, a linear model, a generalized linear model, general additive model, or a low S function, right? And so again, it comes with that default value, but you can override that to give a different kind of smoothing curve. So just to orient you to the fact that there are some other parameters that you can pass to some of these functions. Okay, that's going to do it for this video, and with that we wrap up our section on data visualization with ggplot. I hope you got a number of tools in your tool belt and feel confident now to create visualizations of your data.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.